In this video, I wanted to talk about trusses. So I have some notes written here. So in a truss, all of the members are going to be two force members, which means they're either going to be in compression or tension. All the members are pin connected, which is why they're all two force members. You're going to ignore the weight of the members and say that it's negligible compared to the applied load. That's generally true. Trusses are only loaded at the joints. And again, because it's two force members, or that's the reason why they're all two force members. And then there are two ways of solving it. One is called the method of joints, and one is called the method of sections. So the method of joints, you typically use that if you're asked to find like the force in every single member. And then the method of sections would be used to find the force in specific members. Alright, I have an example problem here I wanted to run through. So we're asked, find the force in members BC, HC, and HG, and state whether it's in tension or compression using first the method of joints and then the method of sections. So regardless of whether you're doing the method of joints or the method of sections, your first step is going to be to find global equilibrium. So we're going to have some reaction forces here at A and also here at E. So at E, we're only going to have a reaction force in the y direction. So I'm going to assume that's going to go up. And over here at A, we're going to have reaction forces in the x and y direction, since we have loads in both the x and y directions. And then I'm going to assume that this is going down, just because this load here is so large. It doesn't matter if you get these backwards, you'll just end up with a negative answer, and so you'll just have to flip the arrow to bring it to a positive number. Alright, so first thing I'm going to do is take the sum of the moments about A and set that equal to 0. So what do we have? We have 10 kips, that's over 6 feet, and that's clockwise, so that's going to be negative. We have 24 kips, that's going to be 5 feet, that's also negative. And then we have, in the positive direction, we have 12 feet times our reaction force at E. And so that reaction force at E is going to come to 15 kips. Okay, and then we can do the sum of the forces in the y direction to solve our reaction force at A in the y direction. So our reaction force in the y direction at A is going to be 5 kips. And then in the x direction, we only have 2 forces there. So we have negative RAX and positive 24. So the reaction force at A in the x direction is going to be 24 kips. Okay, so now that we have global equilibrium, I'm going to go ahead and just label it up here. So we got 15 kips, 5 kips, and 24 kips. So now we can start going through each joint, or using the method of joints. So to use the method of joints, you have to pick a joint and solve for all the forces coming off of it, which would be the force in each member. And the only restriction is that you can only have two unknowns, because if you think about it, we're in 2D space and it's a point load, so all we have to do is the sum of the forces in the y and the sum of the forces in the x. So we're interested in this member here, BC, HC, which is this one, and HG, which is this one. Now, I can't just pick one of these because all these are going to have more than two unknowns. But if I start over here at A, I have my two reaction forces, and then I only have two members coming off of it. So that's two unknowns. So what I'm going to do is draw like a little free body diagram of A. So we got 24 kips, 5 kips, and then we have our member force AH and our member force AB. So we have an angle here we can find real quick. So that's going to be the tangent of the opposite, which is 5 feet, or adjacent, is 3 feet. I'm sorry, that should be arctan. So that's going to be 59.04 degrees. Sorry about that, just forgot to make that be the tangent inverse. Okay, so we should have enough information to go ahead and solve for these member forces, AB and AH now. So if we do the sum of the forces in the y direction, set that equal to 0, we have -5, and we have plus our member force times the sine of that angle. And so our member force in AB is going to be 5 divided by the sine of 59.04, which is 5.83 kips. And then for AH, we can do the sum of the forces in the x direction is 0. So we have -24, then we have positive 5.83 times the cosine of 59.04, and then plus our member force AH. So then solving for AH, we're going to get 21 kips. Okay, so neither of those are what was asked for, but now we have the member force here and here. And so we can start looking at joints B and H and see what we can do there. So at H, we're still going to have three unknowns, which would be BH, HC, and HG. So if we look at B, though, we only have two unknowns remaining. So let's go ahead and look at joint B now. So we have our force AB right here, which is 5.83. And then we have BC and BH. Make sure I drew those right, yep. Okay, so just looking at this, I'm going to flip the direction of BH, because we already solved for this load here, which was AB, I believe. Yes. We already solved for AB and found that it was in tension, which means it's pulling on the joints at either end. So we know that's in the right direction. And since our forces have to balance, this one has to be pointing up, and this one has to be pointing to the right. Okay, so, and then this angle here, it's just going to be 90 degrees minus 59.04, which is 30.96. And since we only have two forces here, so this should be pretty easy. we set that sum of the forces in the x direction equals 0. We get BC minus 5.83 times the sine of 30.96. That's going to be 3 kips. And then the sum of the forces in the y direction is 0. And so that's going to be BH minus 5.83 times the cosine of 30.96. So BH is going to be 5 kips. So from our question statement here, we're asked for BC, which we just found. And so now we need to state whether that's in tension or compression. So since that's pulling on the joint here, that's in tension. So there is our first answer. So now we've solved at joints B and A. So now we can go ahead and solve at joint H, because we have these, we have BH and we have AH, so that leaves us with only 2 unknowns. Okay, so we got AH right here, which is 21 kips, and that is in tension. We have HG, which we don't know yet. We have BH, which is 5 kips, and that's actually going to be in compression, because if you look up here, it's going towards the joint, so it's going to be in compression. And then our last one is HC. So it's HC and HG are the last 2 that we're looking for, so we should be able to get this question solved just from looking at these 3 joints here. Alright, so to start we can do the sum of the forces in the x equals 0. First let me do this theta. So this is going to be the same theta as from over here, because the dimensions are the same. So theta is 59.04 degrees. So the sum of the forces in x, we have Hg. Then we're going to add Hc times the cosine, 59.04. And then we're going to subtract 21 from that. And then, I guess I should have done the y direction first. In the y direction, we have negative 5 kips, and then we have plus Hc times the sine of 59.04. It's going to give us Hc equal to 5.83 kips, and that is in tension, because it's pulling on the joint. Okay, and then back solving for fx, for hg, is going to be 18 kips, and that is in tension. Alright, so we've answered the question, the first part of the question, which is the method of joints. And so now we're going to do the method of sections, and we should get the same answers. So let me, sorry, I'm just trying to copy this to move it down. Alright, so for the method of sections, like I said earlier, the first step is to find your global equilibrium, which we already did. And then what you do is you cut the truss. and you want to cut the sections you're looking for. And the only restriction on that is you can only cut up to 3 sections at a time. So we're looking for BC, HC, and HG. So we can make a cut right there. And then we're going to draw a free body diagram of that. And then the members we cut, we got BC, HC, and HG. And then our reaction forces. And then basically we're just going to solve for equilibrium about A now. So the first thing I'm going to do is the forces in the y direction, because I only have one unknown in the y direction. That's going to be the sine of 59.04. And then we have minus 5. So HC is 5.83 kips, and that is in tension because we're pulling on the joint. Okay, now if I do the sum of the moments about A, that's going to get rid of HG. That'll drop out, so that'll help us solve for BC. So again, this is 5 feet, this is 3 feet. So we have negative 5 times BC, and then positive 3 times HC times the sine of 59.04, which we already have. HC is 5.83, so then BC is going to be 3 kips. That is in tension. And then for the last one, we can do the sum of the forces in the x direction is 0. Get negative 24 plus BC, which is 3, plus the x component of HC, which is 5.83 times the cosine of 59.04, and then plus HG. So HG is going to be 18 kips, and again that is in tension. So as you can see, we have the same answers, which is what we should have gotten, because this is just 2 different ways of solving the same problem. Now, the method of sections is a lot simpler in this case, because we didn't have to go through 3 different iterations. So that's just kind of to demonstrate that if you have to solve for every single member, the method of joints is really your go-to. But if you're asked for specific members, the method of sections is generally going to be easier. But yeah, I hope this helps.